Muscular system by talking about detrained muscles. We have three different objectives for this short lecture. And so we're going to talk about nuclei, training and detraining, and then muscle memory. Now it's important to remember that muscle cells have multiple nuclei, and the reason being is that muscle cells are relatively big, they're long, and with all the protein synthesis that's occurring, one nucleus isn't enough to sustain what is needed. And so we have these, or there are lots of nuclei in these muscle cells, and they're distributed relatively evenly throughout the muscle fibers. Now, all of you are either in AMR, exercise science, and so something that you're probably aware of is that muscle size constantly changes, okay? So that your muscle can either get bigger when it's trained, we call this hypertrophy, or it'll get smaller when you don't train or when you detrain, we call that atrophy. So I want you to think for a minute, what do you think happens to the number of nuclei under both of these conditions? So what happens during hypertrophy? What happens during atrophy? Well, with training, this shouldn't be too much of a surprise, but the number of nuclei appear to increase. And the way this works is you've got satellite cells, and they will come and they will bind with muscle fibers, and they basically release extra nuclei. Okay, and so I'm going to try and draw this here. And it's going to be terrible, but we're going to at least give it a go. Okay, so here's my muscle fiber, right? And here's, we'll just say there's one nucleus here. But it gets bigger, and so what happens is we have these satellite cells, okay, and there's a little nucleus in it. It's going to come and it's going to bind, right? And so here's my little satellite cell binding, and we've got another nucleus, and maybe you got another cell binding here, and another nucleus, right? And so what this will ultimately do with these satellite cells is this helps get the muscle to be bigger. All right. However, the number of nuclei doesn't seem to be affected by detraining. Okay. And so you keep the same number of nuclei even though your fibers get smaller. And this could also be the fact that we hold on to the same number of nuclei, or that number stays constant, likely what allows people to train or retrain or get back to their previous training state relatively quickly. They've got these they've got these nuclei already. They just need to change the muscle fiber, the characteristics of the muscle fiber. And so we refer to this as muscle memory. All right, like I said, likely due to the increased number of nuclei. And that is where we're ending the neuromuscular unit.